Okay, so we're going to be proving that when n is greater than 1, that these two equations hold true. So first off, we need to establish our premise. So we're going to use p of 1, because that's our lowest one that we can use, and it's our most simple. So p of 1 is equal to 1, and then if we plug it in both equations, we get that's true. Moving on, we're going to make a p of k instead of n, and we're going to assume this is true when we change all our n's to k's. So we get 1 plus 2, 2 factorial plus k factorial is equal to k plus 1 factorial minus 1. And we're going to, again, assume this is true. Now we're going to make a new substitution, and we're going to call it k plus 1. And so basically we're going to do the same thing. And then right here, we're going to add our k plus 1s in. So wherever there's a k, make it k plus 1. And then on our right-hand side, we'll have k plus 2 factorial minus 1, putting a k plus 1 basically in there. Okay, so our next step is we're going to notice that these two equations highlighted in blue are equal, so we're going to make a substitution. So that's how I get to this step right here. And then so I say k plus 1 factorial minus 1 plus k plus 1 factorial k plus 1 is equal to k plus 2 factorial minus 1. And what I'm going to do is I'm just going to get rid of these 1's right here. So those cancel out. And then we're left with this equation right here. And on this left side, what we can notice is that we have k plus 1 factorial and k plus 1 factorial. So I'm going to factor those out. And then once I've factored it out, I'm going to rewrite k plus 2 factorial as k plus 2 and k plus 1 factorial. And I'll show you down below really how that works, because it was hard for me to visualize at first. And then what we can do is we can simply divide both sides by k plus 1 factorial. And now what that leaves us on the left-hand side is k plus 1, which is k plus 2. And we can see those are equal. So to see how we got k plus 2 factorial down to this guy right here, so first off, we can start off with the basics. So 5 factorial is really equal to 5 times 4 factorial, right? And so let's look at like an example of n plus 3 factorial. We can rewrite that as n plus 3, n plus 2, n plus 1, and then n factorial. But what we can really rewrite this as, this portion right here, is we can rewrite that as n plus 3 times n plus 2 factorial, if that makes sense. And that's what we basically did right here, is we rewrote this as k plus 2 times k plus 1 factorial, because this k plus 1 factorial encompasses everything all the way down to just a normal k.